Hello number ones, welcome back to my channel. This is the Metatron speaking and I want to really know your opinion on this. So apparently ancient Roman lead, meaning ingots produced by the ancient Romans made of lead, have been used in the cryogenic dark matter search, which is, as far as I can understand, an experiment that was carried out in Minnesota, and it's a physics experiment. And this has in fact sparked some controversy. On one side of the matter, there is the idea of, well, we could use some material to help us advance in physics and science, then we should use it, whether it be 2,000 years old or not. But on the other side, there is the idea of preserving historical heritage, and particularly in the archaeological and historical community, because, of course, this methodology is destructive in nature. Now, I can see where they are both coming from, but before we can make our own mind, I think we should dig a little deeper. So here is an article about it. It's from Scientific American, and it's titled, Ancient Roman Metal Used for Physics Experiment Ignites Science Feud. Physicists prefer Roman-era lead ingots to recently mined metal for shielding particle experiments, but archaeologists want them preserved. Archaeologists and physicists are at loggerheads over ancient Roman lead, a substance highly prized by both camps for sharply diverging reasons. Very old lead is pure, dense, and much less radioactive than the newly mined metal, so it is ideal for shielding sensitive experiments that hunt for dark matter and other rare particles. But it also has historical significance, and many archaeologists object to melting down 2,000-year-old Roman ingots that are powerful windows on ancient history. So already, I think we need to kind of talk about this. Before we even jump into the actual controversy, maybe some of you might even be surprised by the idea of the Romans had lead, and the answer is absolutely yes. The Romans had access to lead, to tin, to iron, to steel, to bronze, yes, I did say steel, to bronze, to copper, and all sorts of different metals, some of which, unless you actually dive into ancient Roman metallurgy, might even sound modern to you. No, they're not. I mean, yeah, they didn't have titanium, okay? And great, but they did have access to all of these metals. And in fact, I will tell you on this video a little bit about Roman mining on the latter section of this video, so do watch until the end, you muppet. But in general, yes, the Romans did look, seek, extract, and refine lead, and they did have several military and economic uses for it, which we will address later. With that being said, I do understand why archaeologists would be objecting towards the idea of melting down something that is 2,000 years old and has reached us in such good conditions. I mean, at the end of the day, I collect all sorts of old school computers, and already I always try to do the very best, even if it costs me quite a bit of money sometimes when there is shipment involved and there is a CRT. I just always want to make sure that technology that has survived 40 plus years is treated as the antique that it is, with respect and with care. Because can you imagine, like, something it survived 40 years just to be destroyed during shipment? I can absolutely understand, because then you have to multiply that 10 times fold when something is 2,000 freaking years old. I think for me, this would have been worse if it was something artistic. So I would side with the archaeologist if the items being destroyed were helmets, statues, weapons, anything that has been manipulated through craftsmanship, art, military purpose, because yeah, that would be a tremendous waste. But an ingot, not so much of a problem for me, given would I want the ingots to be thoroughly studied and examined before they are used for these physics department and applications? Absolutely. Definitely. At this point, you could even do some destructive analytic methods, which usually archaeologists try to avoid. So oftentimes we use non-destructive methods of analysis, which are not as accurate or as descriptive as destructive ones, precisely because we don't want to destroy elements and items that have survived so many years. But in this case, it could be a win-win in the sense that you could do all sorts of analyses on the metal that can literally help us expand our understanding of ancient Roman metallurgy. And then if there is an application within physics departments that can really help speed up our understanding of science, then at that point I would say, yeah, use it. It's not a big deal. At least that would be me. Once again, if this was instead a beautiful work of art, yeah, no, because at that point we are losing so much that The only way in which I would say yes to melting down a work of art would be complete absence of any other source for that sort of metal or product or whatever it is that they're looking for, constituent. A discovery so pivotal that it could literally throw us 50 years in the future and help resolve lots of problems that are critical to our society. So then it depends. It really is a situation that needs to be weighed depending on what we have to gain. So let's keep reading. Open quotes. Are these experiments important enough to destroy parts of our past, to discover something about our future? Close quotes, says Elena Perez Alvaro, an archaeology graduate student at the University of Birmingham in England, who wrote a paper on the dilemmas involved in Rosetta, an archaeological journal published by the University of Birmingham. Now, just to give you a little bit, I looked her up, and indeed she has a lot of publications, so great, PhD in cultural heritage, if it's this person, but I believe it is, particularly with underwater archaeological preservations of goods that, of course, are historical in nature. We have underwater cultural heritage diplomacy between hybrid warfare and conflict resolution, decommissioning offshore structures and large ships, a threat or an underwater cultural heritage opportunity. So as you see, it seems like she's very active in this idea of preservation, which, once again, as I was saying, I do agree with on principle, but as stated before, ingots are probably kind of on the lower end within the spectrum of value of ancient artifacts. But still, an archaeology graduate student, okay. Some physics argue that getting hold of the metal is worth fighting for, open quotes. These experiments can reveal some of the most fundamental properties of the universe and answer questions such as what are we and where we come from, close quotes, says physicist M. Fernando González Zalba of the University of Cambridge, who collaborated with Perez Alvaro's investigation, open quotes, I think it's worth it, close quotes. Well, to be honest, I mean, these questions, I'm not sure why he put it in these terms, because these questions sound philosophical in nature. I would be more interested in the direct applications of whatever we can gain in the best case scenario from these specific types of, as we read, cryogenic dark matter research. Because at the end of the day, I'm more interested in that. Because I doubt that you can answer some of the deepest questions with this. With Roman lead. So what I do think, however, is that yes, if they tell me no, if we do this, then we will be able to build machines that can push us towards the production of more functional quantum computers, or it can help us understand how the universe works in the sense that now we understand matter better, and so we can do better prediction and help curing diseases, or we can create machines that will help us produce more food more easily. Like, I would like some direct application of why this research you're doing is so important, at least from the public's perspective. Ancient Roman lead has been used in the cryogenic dark matter search, an experiment in Minnesota that aims to detect the particles that make up the invisible dark matter, thought to contribute much of the universe's mass. And given, I mean, the topic is fascinating, absolutely. I'm intrigued. 100%. So I would say, yeah, use the lead. How many do we have? I mean, do you have to use all of them? Like, that's another important factor that we should know, because how many intact lead ingots from the Roman period do we have collectively as a species? Because at this point, it's not even a national matter. Who cares if we lose some lead ingots from this nation? If we have more in the other nation, it's not that big of a deal. Once again, it's a collective thing, because history belongs to all of us. Regardless, if we have many and we lose two, or even if we have 10 and we lose two, yeah, it's a heavy price to pay. But once again, these are ingots, so it could be an opportunity to study them further. The same metal has also been used in the Cuore Cryogenic Underground Observatory for Rare Events project in Italy. Oh my gosh, they called it HART. That's what that means, which the acronym, which will soon begin searching for a theorized particle decay process called neutrinoless double beta decay, which, if found, could explain why matter dominates antimatter in the universe. Yeah, I mean, that sounds great. Use the freaking ingots at this point. These experiments and other require extreme shielding to block out any extraneous particles that might be mistaken for the rare signals they hunt. Makes sense. The lead in question once went into the making of coins, pipes, construction materials, and weapons in the ancient Roman civilization. Absolutely, among other things. It is most commonly found now at shipwreck sites. Yeah, because usually, believe it or not, when you find both organic material but also metal. Underwater preservation is actually excellent because it's either that or it's anaerobic conditions that are, but sometimes the underwater sand, for example, does help preserve metals. It's I know it's counterintuitive because you think if I put metal in water it's going to rust. Well, already rust depends on the type of metal, because not all metal rusts, as it's a reaction to oxygen. But in general, underwater conditions do happen to be some of the best for preservation, and as far as I understand, the only better ones will be complete anaerobic conditions that you do find in very dry weather, climates sometimes, where private companies harvest it and melt down the Roman ingots into standard bricks before passing them on to customers, many of whom are physicists. Yeah, I would like to know who the others are, because once again, if you are melting down something ancient Roman, or Greek for that matter, or Akkadian, yeah, there has to be a reason. So if this involves some black market stuff, then of course I would be very much opposed, and I think in fact it could help. If you can combat the black market better, more systematically, and preserve some of these items like coins, then we would have a bigger pool, and therefore if we have to sacrifice a few for the sake of science, it would be less of a punch in the gut. Open quotes, none of us take it casually. You don't want historical artifacts to be destroyed unnecessarily, close quotes, says physicist Blas Cervera Cabrera of Stanford University, who leads the CDMS project. Absolutely, yeah. Nevertheless, ancient lead is the best material available for shielding dark matter detectors, he says, because it releases so little radiation or background particles. Open quotes, the kind of background level that you are achieving with ancient lead are roughly 1,000 times below that of commercially available lead, close quotes. Yeah, it does sound like this is indeed the best possible material that they could find for this. So once again, personally don't have a problem with them using it, as long as they don't use all of it. All lead mined on Earth naturally contains some amount of radioactive element uranium-235, which decays over time into another radioactive element, a version of lead called lead-210. When lead ore is first processed, it is purified and most of the uranium is removed. Whatever lead-210 is already present begins to break down, with half of it decaying on average every 22 years. In Roman lead, almost all of the lead-210 is already decayed, whereas in lead mined today, it is just beginning to decay. Of course, many lead-210 atoms have already decayed in this ore too, but the supply is constantly replenished by uranium in unprocessed lead. Okay, and then open quotes, the longer since it was originally processed, the lower its intrinsic radioactivity, close quotes. Gonzalez Salva says. So basically, if you manage to find, so this is not necessarily due to the processes and the techniques used by the Romans to process the lead. That's what I thought at first, but no, in fact, it's just a matter of time. So as far as I'm concerned, as far as they're concerned, then if they could find Akkadian lead, or if they even processed it, or if they could find anything even more ancient than Roman, it would be even better at this point. If you're enjoying this video so far, please take a moment to check out my Patreon page. With as little as a $5 support, you can help us ensure that we can continue to produce high quality and high researched content. And at the same time, you get access to polls, extra videos, unlisted streams, and much more. Thank you so much. The Romans were not the first lead brick makers, of course. The ancient Greeks were also manufacturing the building material about 200 years earlier, whereas this lead probably also finds its way into some physical experiment. It is scarcer, and the supply of Roman lead is not exactly plentiful either. Open quotes, we may lose all ancient Roman lead, and therefore the information about ancient technology, shipping, trade, etc. it can offer, if its use for this kind of purpose becomes widespread, says archaeologist John Carman, Perez Alvaro's advisor at the University of Birmingham. I understand the problem here. We don't have that many. If they keep using it, we'll run out of it. Yeah, that would be a problem, but then again, how much can you extract? So here's my thing. That's why I'm saying, if you've got this lead ingot, and you can study it, and you can try to extrapolate all the information you can, at one point you will reach a plateau, because I mean that's it. So I do say study as much as you want, study all you can. Where was it found? How was it made? What kind of constituents does it have? Let's do a full-on analysis. Let's try to figure out if it had any specific way in which it was forged, what kind of, not forged, but produced. But once that's been exhausted, what's that ingot gonna do? Stay in a museum? So at that point, I would preserve a few. I would not. Like, I would say that, okay, if we've got 2 left, no, let's go and look for more at that point. But I would take, what's the need to have 70 ingots as opposed to 15 if we can help progressing science. An ingot is an ingot. There isn't as I say, it's not a statue, it's not a weapon that we can learn the manufacturing capacities, and people can actually look at the sword and be like, oh my gosh, look at that, that's a real deal from the ancient period. An ingot is not as precious as fully developed objects and items. It is still precious. So I wouldn't say run out of them completely, but I think there is only so far you can go when it comes to all the information you can get from it before you reach a plateau, and that's it. At that point, it would just be in a museum. So even though I'm someone who absolutely loves the preservation of anything ancient, once again, ingots are a little bit on the lower end of the scale for me. Now let's talk more about Roman metallurgy, shall we? Between the era of Phoenician Mediterranean dominance and the rise of Roman power, metallurgical understanding and experimentation was the domain of the Gallic Celts. It is them, we are told by Pliny the Elder, that invent the very concept of tinning. By tinning, we mean the process of applying a thin coating of tin onto another core metal, effectively creating what we call tin plate. As the Romans step boldly into the historical frame and assert martial dominance, the locating, controlling, and exploiting of tin mines became of paramount importance to central authorities. Roman provincial organization and landscape analysis in connection with the reshaping of provincial economic structures and the Roman enforced occupation will now be discussed. The metamorphosis which occurred to the indigenous populations of these areas and their territories as a result of republican and imperial Roman annexation is significant. The scale and intensity of Roman mining operations in tin-rich deposit areas, which were carried out in order to maximize productivity, and the consequent exploitation framework had a tremendous effect to the socio-political and economic strata of subdued populations. By 19th BC, these included also the northwest of the Iberian Peninsula, becoming the province of Hispania Criterior, as formed by Emperor Octavianus Augustus. Furthermore, not only tin but silver and lead mines were constantly exploited beginning already in the Republican era. All of this reflected not only an insatiable hunger for precious metals, but a high level of demand, which was the result of a jaw-dropping metallurgical competence many may not be aware of. As more and more territories crumble under Roman expansion, we see the birth of an essential mechanism for resource production and population control. A mechanism that speaks to the pivotal role tin, among other metals, had in the ancient world. As a result, Roman territorial involvement left aggressive scars which are still visible after 2,000 years, an everlasting evidence of Roman dominion. The law surrounding this debut is murky. Ooh, let's go into the legal aspect. The 2001 UNESCO Convention on the Protection of the Underwater Cultural Heritage prohibits commercial exploitation of historical shipwreck artifacts. As it should, but this is not a commercial exploitation. Whether that applies to physics experiment is unclear. I think it shouldn't be clear. It's pretty obvious that it shouldn't. It's not for economic gain. It's for the process of science, so it's completely different. Open quotes. Because the final use of the lead is for knowledge, not actually for the marketplace, this lies somewhere in between, close quotes. González Salva says, well, I don't think Mr. Salva should say it. A lawyer should identify this at this point. And already his interpretation sounds incorrect to me. It's not in between. It just doesn't lie within if this UNESCO Convention protection law only speaks about commercial exploitation, then it's outside the spectrum of this law and regulation. Just as a matter of deductive logic at this point. Open quotes, this is where the regulation is not 100% clear about it. Close quotes, let's see. Both archaeologists and physicists say better guidelines are necessary. Open quotes, we need the sort of deep analysis of the issues involved that Elena is undertaking, or Elena, followed by a serious debate involving all interested parties, including international bodies such as UNESCO, to construct a set of clear guidelines that will hopefully protect the interests of the scientific community, including that of archaeology, close quotes, Carman says. Yeah, I think as long as you make it like there are these exceptions and specific scenarios in which we are okay because what we are gaining from it supersedes and in a way trumps what we're about to lose, which is again an historic artifact, then as long as there is that kind of overlap and the historical artifact is its value, because they're not all equal. Not every historical artifact is equal in value and importance and depth of what we can learn from it. So at the end of the day, as long as the value of the object is relatively on the lower end and the amount of what we can acquire as a species is higher than what we can get to lose, then I would say you can do it. And the only thing I would say within the law, unless it's the last specimen that we have, because I mean, in that case, you have to just go and look for more. That's what I would say. But yeah, no, it really is a case-by-case scenario, but I think general, broader definition lines can be used and can be applied to this specific conundrum. Ultimately, all parties seek a compromise that will preserve history yet enable cutting-edge physics. After all, the Romans were famous innovators, yeah, and would probably smile to know how their lost ingots were being used today. Yeah, I mean, to them, the ingots were a tool. So I'd say this is a pretty obvious statement, but I agree with it. But yeah, to them it's a tool. They're like, yeah, of course, yeah, use it. Yeah, that's what it is. But clearly, to put it in perspective, we would have to tell the Romans, would you do it not with one of your tools, but or ingots, but would you do it with a precious ancient Egyptian, whatever the heck that you found? Imagine an ingot that to you is thousands of years old, because do remember that there is a massive disconnect, and I often enjoy mentioning this. So if you're a regular of the channel, you've heard me say this one many times, but as it's often said, Cleopatra is closer to the development of the iPhone than she was to the building of the pyramids. So even for Cleopatra, from her perspective, ancient Egypt was already ancient in ancient Egypt, in the sense that, yeah, the pyramids were thousands of years old for her. So you could do that with the Romans. You could say, how about like if you have an object that comes from ancient Egypt, but really at the beginning of the inception of that civilization, or something like a Mycenaean origin, then would you use it for the progress of your scientific understanding, or in general of knowledge, and see what they would think. But I would have to say, considering how pragmatic the Romans were, they would probably say, oh yeah, do it. But then again, I imagine there could also be some different opinions depending on who the Roman is. Anyways, fascinating, a situation I would have never thought could have happened, but here we are. What do you think, noble ones? Let me know in the comments below, and I will be seeing you for the next episode. Thank you very much for watching, and remember, the Metatron has spread his wings. Goodbye.